good morning, good afternoon, good evening, depending on your time zone. Thanks for having me here. I'm going to talk about some of the challenges and future trends of the deep learning world. I'm going to start with this quote. Soon we will be ashamed of telling our kids we used to drive cars and we had to visit doctors to get monitored. This is indeed true. And the one of the main reasons is the topic of deep learning that is making this to become true. This is the outline of the talk. I'm going to spend 5 minutes on each topic. We're going to go through the hottest trends in deep learning first, and then we're going to see some applications, and then we're going to talk about some of the tools, open source packages you can use in order to make these applications real, and finally some takeaways from industrial experiences. And again, if you have any questions, I'm not sure how the format is for the webinar, but I'm okay if you just jump in and unmute yourself and ask
We will
questions.
have a Q&A. We'll have Q&A at the
Q&A at
end
the
of
end.
the session.
Okay, sounds good.
Attendees can
All right, so
put
I'm
the
gonna,
question.
yeah, I'll try to finish hopefully in like 20 minutes so that we have enough time for Q&A. This is the Trinity of AI. It's the three main components are compute, algorithms, and data. And Um, so AI is not a new term. It's been out for many years, but the recent advancements in compute hardware, like components such as GPUs and FPGAs that have been recently available and accessible, and also very large data sets like ImageNet, which is a baseline, which is like a base reference for all deep learning applications and computer vision and image analysis. And thanks to all of these new technologies, deep learning has been a very a trend, has been like a new trend and a very hot topic these days. As you can see here, the graph, AI is like the whole, any intelligent system, and then machine learning is a subset, and then deep learning is also like a smaller subset of machine learning, even though it's like a small area, but it's a very important topic and has made a lot of impossible tasks to become possible. When we talk about data and how much data we have, um, this is maybe a very nice example to understand the amount of data that we're dealing with. Every autonomous car in average generates data equal to 2,600 internet users. This is because of all the cameras and all the sensors inside the car and this technology that is being collected for enhancing the autonomous system. And also there's like again a lot of white papers out there and a lot of great people out there that coded that this technology is going to be out there in the next 4 or 5 years. So everyone is going to be, or at least most of the people are going to be using this technology soon. So that means we're going to have so much data, right? One example, I mean, I'm sure everyone has seen all these autonomous cars who are used for people commuting to different places. But there's also some new startup companies like Neuro was founded in 2017 in San Francisco that is capable of delivering groceries, pizzas, and other items. So it doesn't really need that So the safety of the passengers is not really critical here because no one is on the car. But again, so it's not about only autonomous driving cars, but it's also about cars which are able to deliver food and stuff. This is There's so many applications of deep learning. This is just one example I wanted to show you, especially because we're right now in the middle of the pandemic. This is like a real-time object detection model, which is capable of detecting whether someone is wearing a mask or not. If they're wearing a mask, you can see them highlighted as green. If they're not wearing it, it's highlighted in red. There's a lot of other applications that have came out recently. You may have seen them. For example, for social distancing, there's some deep learning models. They're able to identify if there's like enough distance between the people walking around using cameras. Some of them are not like super accurate because the camera is just able to is not able to like sense all the dimensions and like the depth necessarily if we don't have all the sensors. But again, like using this video, you can simply use an open source tool to label your images and train a model using deep learning models. Since we're talking about some of the hottest trends, I want to touch GANs, and it's been a very hot topic in the past few years. It stands for Generative Adversarial Networks, and this was created by Jan Goodfellow in 2014, and it's been one of the biggest breakthrough technologies of 2018, as per MIT Technology Reviews. This neural network contains two main components. One is called the discriminator and one is called the generator. They show it with DNG. And so we feed in some real examples and real images to the discriminator, and then some random or synthesized images to the generator. This is a competing neural network. It tries to make all those synthesized images as much as possible similar to the real samples, right? So this is how the GAN is able to generate some very, very real images that look real, but they're not, and they're just synthesized. And this actually created this new topic called deepfake. So deepfake actually came from GAN. And as you can see on the right-hand side, this is an image posted by Jan Goodfellow. He's working for Apple currently, but he came up with this idea in 2014. And you can see like one of those examples of images that have been created. So this is like a synthesis. All these images on the right-hand side are synthesized. None of those people exist in the real world, but you can see like the advancement of GAN from 2014 to 2018, from a small white and black color image all the way to like a very high resolution image that looks so real. And also on the left-hand side, you can see some of the advancements in the timeline, which GAN evolved so rapidly, and it's still in the process of evolving. And so this actually created this topic called deepfake. Like 10 years ago, if you wanted to create a deepfake video, you had to spend hours or like hundreds of hours to produce a video that looks like very near to real in a studio. But today, you can actually produce a deepfake video using open source tools and packages in just like minutes. And this is what has made this so hard to distinguish a deepfake video from a real one. I mean, there are a lot of content and white papers out there about how to authenticate real videos. There was a recent article posted on CNN, I think like 2 days ago, that explained all like how to visually be able to distinguish them from each other. But even sometimes it's not easy to do it visually, or sometimes it's not even possible to distinguish it visually, but there are some other different approaches for authenticating this. Microsoft has also taken some steps for trying to, host some like the real content on a server and then authenticate them so that whenever it gets shared, it has like an authentication stamp on it, so it can be, detected as like the real one, not the synthetic one. But anyway, it's a very, very complex topic, and it's been very again popular these days. If you're interested in generating any of these deepfake videos, well, you can use this open source tool called Avatarify that works on Zoom and some other software tools that you can use to generate deepfake videos in real time. And you will see like the performance of the algorithm is like so it's really fascinating. It's going to be generating these deepfake videos in real time with very low latency. This is the next frontier in AI. We have, so every AI algorithm is combined of three main components: data, priors, and task. Now, so data is obviously one of the main components in any AI or deep learning algorithm. And one of the main concerns and issues in the challenges is that, this part is like unsupervised. So ultimately we want to reach an unsupervised method, but all of the deep learning algorithms currently we have are supervised. So it means you need to label images and you need to define objects and images for sometimes for like thousands of images in order to have your model trained. So this is one of the very big challenges that exist in this world. So it's about data. In the future of this part of this area is going to be like unsupervised. For making the algorithms unsupervised, we need to be able to develop concepts such as concept learning and disentanglement learning, which is a very, very important concept. I have a slide for disentanglement learning, so I'm going to explain it further. And then in priors, one of the issues that we have in deep learning models is that they are not robust enough. For example, for an autonomous car, if you just place a sticker, like a black sticker on a speed limit sign, the autonomous car is going to interpret that as a different sign. That's like a very classical example. It's going to think like this means like stop. So just in the middle of the freeway, the car is going to suddenly stop if it sees that such a sign with those black stickers on it on some particular locations on the sign. So again, the models are not robust enough. In order to make them robust, we need recurrent feedback and we need uncertainty to quantification to be able to, so that the autonomous device, device or system would be able to make right decisions when there's some uncertainty situations. And finally, for the task, we are actually going to make it adaptive. We need to make all these deep learning models adaptive. And for doing that, it's going to be like multitask, and it's going to be working in different domains. And it should be like lifelong learning, so that when like a new case happens, the model should be able to adapt and make the right decisions. This is the ultimate of AI. I mean, you won't believe, but we the I would say like the ultimate destination of AI is to be able to create an intelligent system that operates such as a baby, because the baby has all of those characteristics that we discussed in the previous slide. It knows exactly how to handle disentanglement learning. So disentanglement learning means being able to automatically and in an unsupervised fashion uh, disentanglement and extract the features out of the images or out of the data. And that's exactly what a baby does. A baby is easily able to distinguish an adult from a baby by doing disentanglement learning, by extracting the features and understanding what features cause someone to be an adult and what features cause someone to be like a baby. So they're able to make different reactions to those two different concepts. And they're also able to learn with very limited supervision, even though it takes like some time and some year, but they're able to do that over time and build that skill set. And they're able to do concept discovery, task inference, and learning to compose, robust system noise, and all that stuff. So they all exist in a baby. So the ultimate goal of AI is to reach a baby's capabilities. I'm going to talk about some recent applications of deep learning in addition to, the one like the mask detection application that I talked about at the beginning. And this has been widely used in a lot of factories and a lot of manufacturing sites these days. It's called automatic optical inspection. For short, they call it AOI. So it means using a deep learning model to automatically detect cosmetic or functional defects. So cosmetic defects such as scratches, smudges, missing screws, or like, cracks or anything on the device, to be able to detect this automatically. There's so many advantages of it. The accuracy can be very high comparing to like a human operator. The running time is so low. You can actually run this in like a point few seconds, and instead of having an operator to looking at the device from all different angles for like a few minutes to identify all these scratches and smudges. So this is actually some project we worked on recently, and at Microsoft, which the whole goal here is to use a combination of deep learning and computer vision algorithms to be able to solve this problem. So, this is also one of the distinctions between deep learning and computer vision. I'm just showing this with an example. For deep learning, the model is going to be automatically extracting the features in the images. So that means all you have to do is just label the objects in your image. So on the left-hand side, you can see like 4 images of a surface, that all of the, all of the cosmetic defects have been labeled in the image. Then what you have to do is just pass in a bunch of these like pass and fail examples to a recurrent neural network. They call it RNN. And the output is going to be like detecting these objects automatically. But in computer vision, or I would say like machine learning, it involves a human telling a machine what the defect or what the object should look like. So this usually includes multiple steps of image preprocessing and processing images to detect, contours and different objects that you're looking for. But obviously, it's not going to be doing that, feature extraction itself. The developer should be aware of the features that they want to extract. So this is, the main difference here between these two topics. For the AOI project, we actually use this open source tool called YOLO. Maybe some of you are familiar with this and have used this open source technology. It stands for you only look once, not you only live once. Then this was developed by Joseph Redman from University of Washington a few years ago. We used the 3rd version that was developed in 2018. I think he also has like a 4th version in 2020 that you can use. There's a lot of advantages for using this object detection algorithm. First of all, it's open source. The training time is like super fast comparing to other available technologies. And again, there's and this has been like a very, very hot algorithm these days in the deep learning world. This algorithm has also been used in, for example, in military drones for detecting objects and individuals automatically. I would say, unfortunately, it's being used in those cases. But anyway, it's like open source, so you can use it for any sort of application. This is one example I just want to show you. This model was trained using YOLO. This is like the first version of the model. So you can see like I'm moving the camera. This is just like a very simple, cheap webcam that I'm using here, moving it on my device and locating these, different defects in real time. Even though the model had not seen any of these defects before, like even the color of the defects here, I just created them myself with a pen. So you can see it's like blue color, but in the training data set, there was no existing blue, defect in the training set. This is like another example. You can see like in real time, I'm trying to rotate this device in all different directions. The model is able to detect each of these objects in real time. And again, like training a model using YOLO is like super easy. It just took just like a few hours to train on a GPU. And not many, images were required for getting this to train, maybe just like a few hundred, but not thousands. All right. So I think I have another just 5 minutes to go through my last section. I just want to talk about like Python and R because, these are some of the greatest tools that you can use and they're open source in order to make these deep learning applications to become real. So first of all, because we need to communicate with the computer, we actually need to use some of these open source tools. So just talking about like R and Python, I actually teach a course right now, Introduction to Data Science, and R is the main programming language used in that course. So in that course, I say R is the best programming language. And then I also used to teach another course, Introduction to Programming in Python. In that course, I was saying like Python is the best programming language. But I mean, just to be honest, I think both are great and are very useful. I would say like R is more used for data analysis, for visualization, examples and applications. Python is like a more generable solution and programming language. You can use it for deployment. You can use it for training, testing, all sort of models. Even though the capabilities exist in both R and Python, but again, they're like more specific to specific applications. but both are open source, very hot these days in the job market, and best programming tools that you can use. These are some of the very useful packages available in R, which you can use, like ggplot for doing all the visualization and creating fancy plots. You can use Shiny for creating web applications, DPLYR for manipulating data, Carrot web, the Carrot toolbox for training, testing different models. And then in Python, these are like some of the technologies that we actually use for that AOI project that I mentioned. We use NumPy, we used OpenCV for, you can use it for traditional computer vision, for example, for pre-processing images, for contour detection, detecting lines, detecting pixel defects and all that stuff. Then you can use PyTorch and Keras and TensorFlow for training and building deep learning models. Finally, I'm just going to wrap up in one slide and talk about some of the takeaways from these examples and some of the future trends of deep learning. Even though deep learning is so cool and fascinating, but try to avoid it. And if machine learning is an option, if traditional computer vision is an option, avoid deep learning, because deep learning models are very data hungry. And as we discussed earlier, the future of this is going to be like, ultimately we want to reach an unsupervised approach in deep learning, which doesn't exist right now, which that using just like one snapshot or one image, you could train a complex model, which is not available right now. So that's why currently the recommendation is to stick to an ML approach instead of a deep learning approach, because it has a lot of complexity for training. It needs a lot of images for training. So it's a very expensive and time-consuming process. The future of AI is unsupervised, as we discussed. Disentanglement learning is the next trend, because it's one of the, it's the key component for making deep learning unsupervised. And then R and Python are both great tools, open source tools available for free. And they are, developing so fast these days. So they're very nice tools that you can take advantage of. And also, again, just remember, there's so many open source tools out there. YOLO was just one example. So instead of, inventing the wheel again, make sure that you do enough research on, the task and the project that you're working on, because there's a very high chance that you can find available open source tools for solving that problem. All right, that's all I have. Thank you so much for your time and your attention. I will be available for the next 5-10 minutes for if there's any questions.
Yeah, attendees, you can post your questions in Q&A. That was a good presentation, Mohammed. Like, I will just wait for a couple of minutes for the questions.
Absolutely.
And also, we have an upcoming panel. I'll post you the link to join.
Is it going to be after this, the panel, you said?
Yeah, Mohammed, can you please repeat?
So where's the question? Where are the questions going to be posted right now?
Q&A. In Q&A. There are no questions as of now. 1 second.
Okay, just let me know
One
if there's
question
any.
from.
Mhm.
Yeah. Are you able to see?
No, I'm not sure where
Okay.
it is.
Any particular papers you could recommend for learning more on disegmental learning?
Okay, let me
1
see.
second. Let me copy and paste it in the chat.
Okay, that's going to be helpful. Yeah.
Yeah, I did.
Okay, let me check right now. So, okay, any recommendation for learning more in disentanglement learning? I mean, again, it's a very recent topic. So there are tons of publications in 2019 and 2020. One of the main folks that is working on this, I actually forgot her name. She's a professor at Caltech, but she's kind of like leading this area. So again, there are a lot of papers out there. I mean, so if you're interested, I mean, I can definitely send some links, because right now I have to look them up. It's going to take some time, but feel free to reach out to me on LinkedIn offline, and I will forward you some of the new ones, some of the recent again papers.
One more question. I'll post in the chat.
Sure.
Please explain the dicentennial learning.
Okay. So disentanglement learning means
Disent-
automatically extracting features from the data. Okay. So this is, I mean, it's like very different from feature selection concepts, because in feature selection, you already have the features and then you just, find the optimal subset of features. But in disentanglement learning, the algorithm is able to identify the, all the features out of the data set again automatically. That is kind of what deep learning models are doing. For example, when you feed in, a bunch of images for like a car and a cat, for example, if you want to classify them from each other, the algorithm is able to like find those features inside the data, but it's hard to, to translate them or export those features out of the model, right? So disentanglement learning is going to be an approach which you can run on any labeled images. And hopefully it's going to become unsupervised, which means just running it on like one image, and then automatically exporting the features and telling you like what are the features that cause this image to be a cat versus this image to become like a car. Okay, so it's going to tell you like explicitly, if there's a wheel in the car, it's going to be a car. I'm sorry, in the image it's going to be a car. If there's like a, I don't know, like some animal that has like four legs, it's going to be a cat. Okay, I mean, I'm just like uh, making this like simple, but ultimately that's what we want. So we're not even close to having such a model and algorithm, but this whole topic is called disentanglement learning, and it has become very popular and like a new trend recently, especially after deep learning became a hot topic. This is kind of like the ongoing track. But if anyone is interested, please reach out to me on LinkedIn, and I can definitely forward you some more additional resources.